Welcome everybody and welcome to another Mapwork video. Today we're going to be looking at your magnetic declination and your magnetic bearing, and we will be also looking at your vertical exaggeration. So looking at your first section of your magnetic declination and your magnetic bearing, here it's very important to know that the Earth has a magnetic field, and when you try to find north on a compass, it'll point towards your magnetic north and not your true north. So the magnetic declination is going to be the difference between your true north and the magnetic north on a compass. So this is very important to know because the Earth has a magnetic field which changes over time. So if you can go to the same area a few years later, what you will find is that your current reading will differ from your previous reading. The needle will point in a slightly different direction. Therefore, to calculate your magnetic declination, it's important to take these few things into consideration. We need to know what is the mean magnetic declination. The second thing is in which direction is the magnetic declination, in which year is the magnetic declination given, what is the mean annual change, in what direction is the average yearly change, and for what year must the magnetic declination be calculated. If we find out all of these questions, we are able to accurately locate our place on the Earth's surface. So when you are in a test and exam, your teacher might give you a question. They might give you a map. On the map, you're going to have to look at the bottom of the map, and here you will be able to find the information on your magnetic declination. They generally give you a write-up, and it says that the magnetic declination is 23 degrees and 53 minutes west of true north in July 2002. The mean annual change is 6 minutes towards the west. So now that we have our information, we are able to work out our magnetic declination. So here the question that they might ask you is to calculate the magnetic declination for 2009. This is the current one that they want you to find. Previously, you last worked it out in July 2002. So it's been several years since you have last checked it, and it moves 6 minutes towards the west every single year. So here, if we have to give you an example, it would move 6 minutes in 2003, again another 6 minutes in 2004, and again another 6 minutes in 2005, and so on until 2009. We want to know how far and what is the current magnetic declination for the year of 2009. So firstly, what we need to do is we need to go through to step 1, and we need to calculate our difference in years. So this is quite an easy step. We last checked it in 2002, and we want to know what is it in 2009. So a very simple calculation. Take the bigger number and you minus the smaller number, and that will tell you that there has been 7 years since you have last checked the magnetic declination. Now that we know that it's been 7 years since we last checked it, we know that it moves 6 minutes every single year towards the west. This is our change. So here we need to work out the total change. How far has it moved in those past 7 years? So we take your 6 minutes, we times it by 7 years, and that will tell you that it has moved 42 minutes towards the west. Right. So now our new magnetic declination is sitting over here. So it has moved again 42 minutes towards the west. We want to know what our current magnetic declination is for 2009. So we move on to step number 3. Here we need to add or subtract from the magnetic declination. So we need to know what does west mean and what does east mean. For South Africa, if the change is towards the west, you will be adding. Okay. If the change is towards the east, you will be subtracting. So for our example, we were given a west. So we know that west is going to be adding. So we add your previous magnetic declination of 23 degrees and 53 minutes to the west. And we add on our total change that has been taking place over the last 7 years, which will be 42 minutes. And we need to add these together. So 3 plus 2 will give you 5. 5 plus 4 will give you 9. And then you bring down the degrees, and then your new answer will be 23 degrees and 95 minutes. But remember, minutes cannot be more than 60. So we need to add on 1 more degree. So the way in which we can do that, you minus 60 from your 95, and that will give you an answer of 35 minutes. You take across the extra degree, and that will give you 24 degrees and 35 minutes. This will be our final answer. This is our new magnetic declination for the year of 2009. So if you are able to do this, and if you are able to do your normal bearing, you'll be able to add these together to be able to find out your answers. So if we take a normal bearing, let's say that was 100 degrees, and now we want to add that to our new magnetic declination, we need to add 24 degrees and 35 minutes. That will be a very simple calculation, and here you'll be able to see your new magnetic bearing for that place will be 124 degrees and 35 minutes. So you'll be able to accurately work out where your location really is. The next section that we will be looking at today is going to be your vertical exaggeration. So here again, we have another formula. The formula for your vertical exaggeration is VE equals your vertical scale over your horizontal scale. So here we generally use this for our cross sections. On your cross sections, like we looked at a little bit earlier, you can see your different landscape features. But looking at a cross section like this, we cannot really identify our different landscape features. So we want to exaggerate our vertical scale in order to better show our landscape features in our environment. So what we do, we exaggerate our vertical scale so that we can better show our height above sea level, and that will show you your different landscape features more accurately. But this is not really an accurate representation of your data. We want to know how many times has this vertical scale been exaggerated in order to show this landscape feature. So we work out your vertical exaggeration. So your question in your test or exam may be to calculate your vertical exaggeration of your following cross section. They have given you a vertical scale, and they have given you your horizontal scale. But here we can see that your units are not the same. Here we have a ratio scale, and here we have a different scale of 4 millimeters equals 20 meters. They are not apples to apples, so we cannot compare them together. So we need to change your vertical scale into a ratio scale. So here you take your 4 millimeters equals 20 meters. Here you can see we're working with millimeters and meters. So we need to change these meters into millimeters. So you take 20 meters and you times that by 1,000 to get your answers in millimeters. Now we are working with apples to apples. So again, we have 4 millimeters on the side, but we don't want to have 4, we only want to have 1. So we take it down and we drop our units because they are the same on each side. Here, now we have 4 on this side, but we only want to get it into 1. So we divide this side by 4. So 20,000 divided by 4 will give you the answer of 1 is to 5,000. So our new scale for our vertical scale will be 1 is to 5,000. Now we have a ratio scale on both sides. Now we are easily able to put this into your vertical exaggeration formula. So again, remember to always use your formula. Your vertical exaggeration equals your vertical scale over your horizontal scale. So we bring down your vertical scale, 1 over 5,000, divide, remember it's over, 1 is to 50,000. This is your horizontal scale. But now using maths, we want to change this divide into times in order to be able to work out our answer. So what we need to do is we need to invert this fraction. We put it on top of its head. So here we bring it down, 1 over 5,000 times 50,000 over 1. You put that into your calculator and it will give you an answer of 10. But 10 what? We want to know how many times the scale has been exaggerated. So we know that the scale has been exaggerated 10 times. Please don't ever forget your units at the end of your answer. Your teacher needs to know what you are talking about. So the scale has been exaggerated 10 times. Right. If you have any questions, you are very welcome to get a hold of me. Otherwise, enjoy the rest of your day.